So we'll go through a quick review of the unit 10. So a logarithm, remember, is just the opposite of an exponential. So in other words, to solve an exponential, a lot of times you use logarithms. The first thing we did with that unit was being able to rewrite these things in the different forms. So remember, to rewrite as a logarithm, the base here is 3. So you start with 3. So I like to do the spiral. 3 squared equals 9. Here the base is 10. 10 to the third equals 1,000. And then log base 2, 3 to that. And then let's make sure we can go the other way. So this one to me is a little bit easier because it's set up a little bit better for that spiral. But you end up with 8 to the fourth equals 4,096. And then when there is no base, remember that means that there's a base 10. So that would tell you that 10 to the negative first equals 0.1. So the change of base formula, remember you do log of A over log of B. So for this one, evaluate each using the change of base formula. So that'll be log of 28 over log of 3. And then you can just go to the calculator, and that'll give you the decimal 3.033, round to 1, 2, 3 decimal places. I would just encourage you to be consistent. So for 55, log of 502 over log of 2, and that's 8.97. We'll call it 8.97. And then here we do log of 60 divided by log of 12. I encourage you to make sure you put these things in parentheses. So it's 1.65 rounded to 2 decimal places. Solving equations. So we saw solving equations yesterday, maybe something like 4 to the x equals 16x minus 2, where we could change 16 to 4 squared and then solve that way with like bases. As we cancel those. But the issue with a lot of these exponential equations, there's no way to get 250 to be 6 to the something, equals 250. It just doesn't work. So what we're going to have to use is logs. So rewrite this as a logarithm. So log base 6 of 250 equals x. Excuse me. And now we can use our change of base. So log of 250 divided by log of 6. So log of 250 divided by log of 6 equals 3.08. Sometimes you're going to do a little bit of work before and after. So here, divide both sides by 5. So we end up with 13 to the x plus 3 equals 22. All right, so we've isolated the exponential part. Now there still happens to be a variable. There's some stuff going on in the exponent, but what we need to do right now is go ahead and take the log so we can undo that exponent. So we'd use our change of base here. Sorry, there's not a lot of room. So type log of 22 divided by log of 13, put that in the calculator, end up with 1.205 equals x plus 3, and then subtract 3 from both sides. We end up with x equals negative 1.79. So for 59, we'll subtract 5 from both sides. We end up with 12 to the x plus 3 equals 70. Now do your logs. Log base 12 of 70 equals x plus 3. And now we can go ahead and set up our change of base. So log of 70 over log of 12 equals x plus 3. So log of 70 divided by log of 12, 1.71. And that's, let me kind of rewrite this where we have some room to work. 1.71 equals x plus 3. Subtract 3 from both sides, so x equals negative 1.29. Here we don't have to worry about doing anything before we take the logs. We can just go ahead and do log of 5, log base 5 of 620, excuse me, equals x plus 2. So log of 620 divided by log of 5 equals x plus 2. So log of 620 divided by log of 5 equals essentially 4 equals x plus 2. So we'll subtract 2 from both sides, so x equals 2. Here, subtract 1 from both sides, so we have 15 to the x equals 31. Now we can do log base 15 of 31 equals x. Use your change of base formula. So log of 31 divided by log of 15. And this is one where we actually don't have to do anything afterwards. We can just say x is 1.27. Here, divide both sides by 5. End up with 4 to the x equals 4. And here we have the same bases. Remember, that's like saying 4 to the first. So cancel those out, and x just equals 1. So sometimes you can actually go back to what we know from the previous unit. And then the final properties we kind of looked at here were expanding and condensing logarithms. So the properties of logs, if we have log of x times y, that means we have log of x plus log of y when we expand that back out. If we have division, remember that turns into subtraction when we expand. If there's an exponent, remember we bring that exponent back to the front. And then log of 1, remember that's like saying base 10. So 10 raised to the what equals 1. Well, that's anything raised to the 0 power. So log of 1 is 0. So let's use our properties to expand these logarithms. Here we just have an exponent, so we just need to go ahead and put that 2 out front. So 2 log of x, and we're done with 63. Here, these are all being multiplied, so we have log of a plus log of b plus log of c. Here we're going to end up, we have division, so we're going to end up with log of x squared minus log of y to the 5th. And now use your exponent property here to go ahead and bring that exponent back down to the front. Here, when we have to condense them, we're just going the opposite way with it. So addition is going to turn into multiplication. So you have log of a times b to the 3rd. So remember that 3 is going to go back up into an exponent. Here you got subtraction, which is going to turn into division. And again, addition turns into multiplication.